brushed motors?
Everything's on camera.
I don't care about that. You are live, but it's all the way over there.
And one thing I might add there is... Hi everybody, happy kickoff. My name is Sam Weaver and I'm the visual media team lead for Full Moon Robotics. We're so excited to have you here. Full Moon Robotics is a Robot in 3 Days team based in North Carolina State University, and we're made up of alumni of FIRST teams from all across North Carolina. This is our first year doing Robot in 3 Days, and we have over 20 different students participating.
We're just going to get started on the chassis. Basically, we're going to try to make a drivetrain. We saw the max perimeter is 120, which is the same as last year. So we're going to try to find a chassis that we can make that's about an inch off from both sides. We're thinking about 27 by 31 at the moment. We're going to stick with Colson's for our wheels. We're going to probably do a 6-wheel drivetrain, and or not probably, we will do a 6-wheel drivetrain, and it's going to be chain driven. We're going to use the Versa chassis, and we're going to do a 27 by 31 with the flipped 6-gear gearbox from West Coast Products.
So our plan is we're basically going through the documentation on FIRST website and building the robot, Sam's robot. So essentially all of the wiring. Our goal is to have like the veins of the robot built out on this table.
Vision's going to be interesting this year. Retroflective tape, I think everyone's pretty familiar with that, and getting targeting systems, and targeting again is going to be really awesome, especially with the 2 different depths of goal. But vision systems for color, we haven't seen that in a while. And so I think getting the color sensor and then maybe an encoder on an actuator arm, right, spinning that wheel, programming wise, is going to be an interesting task to tackle.
So this year we're doing the traditional West Coast drivetrain. We're running into some issues right now with just tools that we have not being the correct ones for the job, so we're tracking down the right saw blades and everything so that we can cut it safely. But now we're getting the chain sized out, making sure that we don't have to worry about half lengths and everything else like that, and just generally laying it out so that the size of our chassis can kind of dictate our strategy talks that are about to come. Alright, so this year we wanted to use West Coast Drive. Kit Parts Drive is very common, very practical, but we wanted to show teams ways that you could further your drivetrain to make it lighter, make it faster, more dependable, and just show teams in North Carolina that there's other options besides the kit of parts, despite the fact that it is dependable.
What we're talking about is a robot that is low to the ground. It is below 2 foot 4 inches and capable of going underneath the trench, having taken balls from the intake and then delivering those to the 1-point goal of the other side of the field. And then in addition, completing the control panel activities by rotating the control panel wheel and ideally, if possible, climbing. That outlines our strategy and kind of the order of operations. And so it follows in that order: dumping, manipulating the control panel, and then climbing.
So this is where we're at right now. We have this that is now installed, drop down, and then suck balls up and toss them back to right about here. And then we're gonna take these aluminum strips and build a guide through the robot and a mechanism that will carry this up, and then flywheel shooter, or dumper, I guess. And then we have our hook placement is coming along. We have the hook that will latch onto the bar, and then when the robot climbs, it will cinch tight around the bar. That mounts on here. We're working on getting the slide rigged, so this goes way up to place the hook. And then the last thing we have going on over in this corner is We have the mechanism to do the control panel, spin the wheel. It'll mount on this back corner. We have a piston to extend so that we can be low enough to go through the trench and high enough to spin it. And then just a motor, one of the 775s with a gearbox to actually do the spinning. We've got our climbing mechanism here.
We have worked on the
We have a telescoping lift to place this hook mechanism. So can we bring the telescoping up? We don't have the string on it yet that's going to power it, but we'll get that on tomorrow. And then this latch is closed,
and then pull.
and then the robot will pull, start to winch up, and this will detach. It's not like that.
Oh yeah. And then this will detach.
And then the robot can pull up on that. And as the robot pulls, it actually closes this because the way the loop is done, so that we can't fall off. Yeah, that should work.
Oh boy. Oh boy.